Mastering deep learning. AI language models devour vast linguistic data to fuel deep learning, NLP, and machine learning applications. How do these artificial intelligence systems, known as language models, process and analyze vast amounts of linguistic data, and in what ways are they utilized in various applications of deep learning, natural language processing, and machine learning? Language models, a subset of artificial intelligence systems, are specifically designed to process and analyze vast amounts of linguistic data. These models are capable of learning patterns, relationships, and structures within language data, enabling them to generate human-like text, summarize documents, and even converse with humans. The process of processing and analyzing linguistic data in language models can be broken down into several stages. 1. Data collection. Large datasets of text, often referred to as corpora, are gathered from various sources such as books, articles, websites, and social media platforms. These datasets can range from millions to billions of words. 2. Pre-processing. The collected data is then pre-processed to remove noise, punctuation, and special characters. This step helps to normalize the data and prepare it for model training. 3. Tokenization. The pre-processed data is then broken down into individual units called tokens. Tokens can be words, characters, or subwords, smaller units of words. This step enables the model to focus on the individual components of language. 4. Model training. The pre-processed and tokenized data is then fed into a deep learning model, typically a type of recurrent neural network, RNN, or transformer architecture. The model learns to predict the next token in a sequence, given the context of the previous tokens. 5. Model optimization. The model is optimized using a loss function, such as cross-entropy loss, and an optimization algorithm, like stochastic gradient descent, SGD, or ADAM. The goal is to minimize the loss function, which measures the difference between the model's predictions and the actual output. 6. Inference. Once the model is trained and optimized, it can be used to generate text, classify text, or make predictions about unseen data. Language models have numerous applications in various areas of deep learning, natural language processing, and machine learning. 1. Text generation. Language models can generate content, such as articles, chatbot responses, or even entire books. They can also be fine-tuned for specific tasks, like generating product descriptions or chatbot responses. 2. Language translation. Language models can be used for machine translation, enabling the translation of texts from one language to another. 3. Sentiment analysis. By analyzing the sentiment of text data, language models can determine the emotional tone or attitude behind a piece of text. 4. Named entity recognition. Language models can identify and extract specific entities, such as names, locations, and organizations, from unstructured text data. 5. Question answering. These models can be fine-tuned to answer specific questions based on the context of a given text or passage. 6. Conversational AI. Language models are used in chatbots and virtual assistants to understand and respond to user queries. 7. Speech recognition. By analyzing audio data, language models can transcribe spoken language into text. 8. Text summarization. Language models can summarize long documents or articles, extracting the most important information and condensing it into a shorter form. In conclusion, language models are powerful tools that can process and analyze vast amounts of linguistic data, enabling them to generate human-like text, summarize documents, and even converse with humans. Their applications are diverse and continue to expand into various fields, including natural language processing, machine learning, and deep learning.